Hello. In this video, we're going to go over problems 23 through 25 from the North Carolina Released Common Exam for Math 2. You can find more information about this common exam and other common exams by following this link. Let's get started. Angles F and G are complementary angles. As the measure of angle F varies from a value of x to a value of y, the sine of F increases by 0.2. How does the cosine of G change as F varies from x to y? Alright, so highlighting some key information here. F and G are complementary angles. The measure of angle F varies from a value of x to a value of y. Thus, the sine of F increases by 0.02. So as the measure changes, the sine of F increases by 0.02. How does the cosine of G change as F varies from x to y? So some key information here that we're going to use that's very important. F and G are complementary angles. Now, that screams geometry to me. So we've got to draw this out. Anytime you see a geometry problem, make sure you have a picture to go along with it. I always say, when in doubt, draw it out, but just anytime you see those, just draw it out. So here we go. We're going to draw some complementary angles. All right, so complementary angles means they add up to 90 degrees. Okay, so here we have, I'm going to let this top one be F, and the bottom one be G. And we're not going to put any kind of degree measure on here, because then, it'd be a specific F and a specific G, and we want these to be very generic. All right, so now the cosine and sine part makes me think of right triangles. So one way to make these things right triangles is by drawing a altitude to each side. All right, so now we have this little rectangle with angles F and G over here in the corner. All right, now say rectangle because if we look at the point where they meet this line, the x value is going to be, if we let this be a coordinate plane, the x value would be my distance from here to here. It would also be my distance from here to here. So let's actually see what the sine of f would be. By the way, the hypotenuse for both of these triangles is the exact same. All right, so the sine of f, the sine of angle f, is going to be the opposite side, which is x, over the hypotenuse. The cosine of g is adjacent, which is x, over the hypotenuse. If you notice, these things are the exact same. So as the sine of f increases, the cosine of g is also going to increase by the exact same amount. If t is an unknown constant, which binomial must be a factor of 7m squared plus 14m minus tm minus 2t? Okay, so this one, we mentioned factors. Now, there's a couple ways to factor. The way that I always think of when I see four terms is factoring by grouping. So let's group the first two terms. Let's group the last two terms. The GCF of 7m squared plus 14m is 7m, because 7 goes into both 7 and 14, and m goes into both m squared and m. All right, so when we factor out a 7m, we divide each term by 7m, and so we get m plus 2 when we do that. Now in the second one, you'll notice both signs are minus or negative. This one right here is plus or positive, so we have to get rid of that negative there by factoring out a -1. Now, the other GCF for these is just t. So when I factor out a -t, divide each part by -t, I get m plus 2. So once again, I'm left with something where I can factor out the GCF. The GCF of this term and this term is m plus 2. So I'm going to factor out an m plus 2. What I'm left with is 7m minus t. All right, now looking at this and looking at my answer choices, 7m plus t is not the same as 7m minus t, so that's not the answer. The one that is the answer is right here, m plus 2. The value v of a car can be modeled by the function v of t is equal to 13,000 times 0.82 to the t power, where t is the number of years since the car was purchased. To the nearest tenth of a percent, what is the monthly rate of depreciation? All right, so they give us a yearly depreciation equation there, and then they ask for the monthly rate of depreciation. That kind of doesn't make much sense to me. If you're only compounding it once per year, how can you figure out the monthly rate? Uh, and so me and a few other teachers looked at this problem. We did it several different ways, and we had several different ways that actually work for this. The one that seems to make the most sense uh, is, to me at least, is this way. It's also the shortest way, so you might like it. All right, so we're wanting to figure out the monthly rate of depreciation. What I'm going to do is I'm going to figure out how much it depreciates in 1 month. Okay, so since there's 12 months in a year, that's 1 out of 12 since the t is in years. All right, so we're going to figure out the value based on that. Okay, so time right there is 1/12. Now when we do that, we get about $12,786.78. Now we need to figure out how much it depreciated. So we're going to subtract this from 13,000. So we've got $13,000. We're going to subtract $12,000, $12,786.78 from it. And when we do that, we get $213.22. Okay, so we got to figure out what percent of the original $213.22 is. So we take $213.22, we divide it by the original to get the percent. Okay, and that's going to be about 0.01, no, not 0, yeah, 0.0164. Okay, which as its percent would be about 1.6%. Okay, so this was the amount it changed in 1 month over the total amount, and that's how we found our rate of depreciation is 1.6%. Number 25. Which expression is equivalent to 16 x to the 1/6 y to the negative 2 divided by x to the negative 1/6 y to the 6th, all raised to the 3/2 power? Okay, now you can do this one a couple different ways. You can either simplify the inside first, or you can get rid of the 3/2 power up here first by distributing it in. What I'm going to do is I'm going to simplify the inside first and then do the 3/2 power thing. All right, so there's several properties of exponents we can use on this. A couple that I'm going to be using is whenever you combine whenever you multiply like bases, you add the exponents. So when you divide like bases, you subtract the exponents. And power to a power, you multiply. All right, so the 16 doesn't have anything to combine with, so it's going to stay like it is. Okay, the x to the 1/6 and x to the negative 1/6. That's going to be, since I'm dividing like bases, I'm going to take 1/6 and I'm going to subtract negative 1/6 from it. All right, and then let me, I'll do too big of a parenthesis there. Let me fix that. And then we have y to the negative 2 minus 6. It's all to the 3/2 power. Okay, so this is going to be 16 times x to the 2/6 power, y to the negative 8 power, all to the 3/2 power. All right, now you might notice this y has a negative on it. Now the way I always explain negative exponents, or the way I get students to remember what to do when there's a negative exponent, is that this is kind of like the y is going on a trip. The 8 here is its luggage. The negative is its ticket. It's going on a trip to the other side of the fraction bar. Okay, now by the way, 2/6 reduces to 1/3, so. Alright, so it's going on a trip to the other side of the fraction bar. Now when it goes on this trip, it uses its ticket, but it keeps its luggage. And this is all to the 3 halves power. All right, so now I can distribute that 3 halves. So we've got 16 to the 3 halves power times x to the 1/3. Now, power to a power, multiply. So this is going to be times 3 halves. All over y to the 8 times 3 halves. Now, the top number is your exponent. The bottom number is your index whenever dealing with rational exponents. Okay, so this is going to be the same thing as the square root of 16 raised to the 3rd power. So the square root of 16 is 4. 4 raised to the 3rd power is 64. Okay, when you multiply fractions, you multiply the top, then you multiply the bottom. So 1 times 3 is 3. 3 times 2 is 6. Now on the bottom, 8 times 3 is 24. And then it's a 4. And then the 2 goes on the bottom. All right, so last step here, I got to simplify my fractions. So I've got 64. X to the 3 divided by 6 simplifies to 1/2. All over y to the 24 divided by 2, which is 12. So there's my answer. All right, so that would be the same thing as D. Once again, you can do this one several different ways. This is just the route that I took this time. I think I've done it different every single time. All right, well, I hope this video has helped. If you have any questions, please feel free to leave a comment, and have a good one.